Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with the last section of the chapter for Chapter 8, which is 8.6. This section is about solving exponential and logarithmic equations. Our central question is, how can we solve exponential and logarithmic equations? So, an exponential equation is, let's go ahead and fill in this. They are equations with a variable in the exponent. That is an exponential equation. The equation with a variable in an exponent, or in the exponent, okay? So it says, what value of x is the solution to 3 to the x equals 30? Well, we'll solve that in a second here, but to find the solution of an exponential equation, we're going to take the log. If you recall, the log is the inverse operation to an exponential. So we're going to take the log of both sides, and we may need to simplify one or both sides of the equation first, okay? Just like when we would need to distribute and combine like terms with solving equations, regular equations, we may need to do some kind of, simplifying and kind of messing around with things to make them work out nicely for us, okay? All right, sounds good. So let's go back to this example right here. We have 3 to the x equals 30, okay? This is an exponential, so the way we undo an exponential is we can take the log or natural log of both sides. So I'm going to take the log of 3 to the x, and that equals 30. Actually equals log of 30, whoops, there we go. Okay, and so we're actually going to, we'll take just regular log for these kind of problems, unless we have e somewhere in the other equations, then we'll use natural log, okay? But for the most part, we're going to be using regular log here, okay? So we have some properties of logs now. So what do you notice about this x up here? Well, with this x, we can drop that right down in front using the power property, which becomes x times log of 3 equals log of 30. All right. Now, how do I solve for x? Well, log of 3 is a number, so we can divide by numbers to get rid of this. If we're multiplying by a number, we can divide by a number. We're going to divide by log of 3 on both sides. So we get x equals, and then log of 30 divided by log of 3 is not equal to it, but equal to it. It's approximately, we're rounding, approximately 3.096. And there is our answer. All right. Okay, if you'd like to try some of these on your own, you can, but some of these are kind of tricky, so I'm just going to keep going through these together, but if you'd like to pause the video and give them a try, you can feel free, but we're going to continue. All right, number 2, we have 4 to the 2x equals 32 to the x minus 1. So in this case, we have logs, or we have exponentials on both sides. And so we can't actually take the log of both sides right away. That's not going to help us really. I mean, we could, but it's going to make it kind of messy. So what I would probably do first, and this goes for other types of problems as well, is I would try to convert 4 and 32. There's a relationship between 4 and 32 that we can look for here. What's the relationship between 4 and 32? Well, if you look, 4 equals 2 squared. So we can do 2 squared to the 2x. And then we want the same base, basically. So how do we write 2? 2 to the what equals 32? Well, 2 to the 5th, right? So this is going to help us. We do this. The x minus 1. So now if we have this, we're going to have a common base. If you have a common base on both sides, if you have a common base on both sides, you can just cancel them out and just take whatever's in the exponent by itself here. So you'll see why we're doing this in a second here, but just hopefully you see why this works. 2 to the 2nd is 4, and 2 to the 5th is 32. So let's go ahead and simplify this now. We're doing power rules. We're going to do 2 times 2x, which is going to be 2 to the 4x. Which equals, then we have 2 to the, then we're doing 5 times x and 5 times negative 1, which is going to be 5x minus 1. Now, how does this help us? Well, if we have, 2 bases that are the same and we have different exponents on top, we can set the exponents equal to each other. So we're going to do 4x equals 5x minus 1. All right, now I got to solve for x, so I'm going to subtract 5x from both sides. So I get negative x equals negative 1. How do I solve for x now? I'm going to divide by -1 to get that by itself. I'm going to get, oops, I goofed up here. It should be 5x minus 5. Whoops. So you're not going to see what I've been writing here for a little bit, but so it's going to be 5x minus 5, and we have -5 divided by -1, which is going to be x equals +5. Okay. So see if you can simplify the both sides first. So if you have different bases, see if you can like rewrite them with the same as an exponent of the same base. Okay. All right. Next problem. We have number 3. 18 equals 4 to the m minus 6 power. All right. So we don't have exponents on both sides, which is nice. But we have an exponent here. We need to get down to the main level. You know, it's kind of like it's in super text right now. So we're going to take the log of both sides. That's going to help us do that. So we're going to do log of 4 to the m minus 6. And now we can use properties of logarithms. We can bring this m minus 6 down out in front. So now I have log of 18 equals m minus 6 times log of 4. Now I want to get that m minus 6 by itself here. How do I undo multiplying by log of 4? Well, it's a number, so I can divide by log of 4 on both sides. Divide by log of 4 on both sides. These cancel out. Log of 18 divided by log of 4 is approximately 2.085 equals m minus 6. And how do I solve for m now? I'm going to add 6 to both sides. I get m is approximately 8.085. All right, and there we go. So these are a couple more examples. Let's do one last example on this part, and we'll move on to logarithmic equations. All right, we have 6e to the 5x minus 4 equals 21. So in this case, we want to get the exponential by itself first, just like we would have if we had 6x squared equals, or minus 4 equals 21. We want to get the x squared by itself. We're going to do the same thing here with the e to the 5x, okay? So first thing I'm going to do is I'm going to add 4 to both sides. So I get 6e to the 5x equals 21 plus 4 is 25. Now I need to get rid of that 6 in front. I'm going to divide by 6 on both sides. So I get e to the 5x equals 25 divided by 6 is going to be 4.17. Now, how do I undo e to the 5x? Well, I do the natural log of both sides. I'm going to do natural log of e to the 5x equals, I got to do it to both sides too, natural log of, 4.17. Now we have properties of logs, so we can bring this 5x down out in front. So we have 5x natural log of e to the, not of e to the what, just e. And we got natural log of 4.17 over here. All right, natural log of e, these are going to cancel out, and we get 5x equals natural log of 4.17. How do I solve for x now? I'm going to divide by 5. And I get x is approximately 0.29. Okay. So, if you're doing e to something, you need to do the inverse operation, which is natural log. If you're doing an exponential, you usually want to do the log of something, okay? All right, moving on. Logarithmic equations. A logarithmic equation is an equation with a log in it. Okay? So one thing I want to mention here sorry, I got confused for a second. If we take the natural or log of a negative number, say we have let's see here. Log of a negative 100 equals y. So for example, can we do this? Is this an actual thing? Let's take a look here. This is going to be 10 to what number equals negative 100? Is there any value we can plug in for y that's going to give us negative 100? Because we do 10 to the negative 2, that'd be 1/100th. It actually wouldn't be a negative 100, okay? So one thing I want to keep in mind here, you actually cannot take the log of a negative number, okay? So that's going to be, whenever you get something like that, it's going to be undefined. Okay, it's only defined for numbers that are greater than 0, okay? All right, just keeping that in mind, let's move forward here. So we have, what is the value of x? What value of x is the solution of log base 2, log base 2 of negative 8 equals x? Well, in this case, let's take a look at this here. This is saying 2 to what power equals negative 8. Is there any number that can work with this or no? The answer is no. So this is going to be undefined. So that's all we need to put for that, okay? So one thing we're going to put over here is can't take log of a negative number. Can't take the log of a negative number, okay? So keep that in mind. Whenever you get something like that, it's going to be, like when we're checking for extraneous solutions, that would be no real solution or an undefined solution, okay? All right, let's get into some examples here. So we have log base 3 of 2x minus 1 equals 4. So the way we undo logs is that we're going to take them to the exponent. So I'm going to do 3 to the 4. We'll push this up here. We're going to have 3 to the 4th equals 2x minus 1. Okay, and then we're going to solve this from here now. So what's 3 to the 4th power? That's 3 times 3 times 3 times 3, which is 81 equals 2x minus 1. How do I solve for x now? I'm going to add 1 to both sides. I get 82 equals 2x. Solving for x now, divide by 2. And I get x equals 41. But we have to check for extraneous solutions. We need to see if this is going to be true or not. So I'm going to plug in 41. So I'm going to do log base 3 of 2 times 41. Oops. Minus 1. Equals 4. Well, that's going to be log base 3 of what? 81. Yep, 81 equals 4. Well, that's 3 to the 4th equals 81. Is that true or not? Does 81 equal 81? It does. So that's going to be so 41 is a solution. We checked for an extraneous solution. Okay. Why don't you see if you can try a couple of these on your own, and we'll go through them in a second. All right, number 2, we have 5 natural log of x plus 3 equals 12. So same thing here. We want to get the log with the variable all by itself. Okay, so same thing we did over here. We want to get that. The log is by itself already for number 1, but now we needed to get rid of the log by doing the exponent here. Okay, so I have 5 times natural log. I'm going to divide by 5 first here to get this by itself. So I'm going to have natural log of x plus 3 equals, then 12 divided by 5 is 2.4. So now the natural log with the variable is by itself. So now I need to undo natural log by doing what? Well, I'm going to do e. We're going to, natural log is base e, so we're going to go like this. We're going to push this up like this. So we're going to have x plus 3 equals e to the 2.4. All right, and then the last thing to do to get x by itself is to subtract 3 from both sides. And we're going to get x equals e to the 2.4 minus 3 is approximately 8.023. And then we have to check for extraneous solutions again. So we're going to plug in 8.023. So we have 5 natural log of 8.023 plus 3 equals 12. And if we multiply that out, we should get 11.9999, which equals 12. That's pretty much the same thing. We just have an approximation, so that's going to work, and that's our answer. Okay. All right. Number 3 is kind of a hard one, because we're going to have to do some factoring, which is kind of a throwback. So we have log of x plus 2 plus log of x minus 1 equals 1. All right. So we have properties of log. Say we can combine these together. So we're going to do log of, we're going to do x plus 2 times x minus 1 equals 1. So that's going to be log of, combining those inside the parentheses, we're going to get x squared plus x minus 2 equals 1. So now we simplified inside the parentheses. Now we need to get rid of that log to get the x by itself. So I'm going to take this 10 and then go over here, push this up. So we're going to have x squared plus x minus 2 equals 10 to the first power. Now we need to solve this. This is a quadratic, so we need to get it equal to 0. So I'm going to subtract 10 from both sides. Get x squared plus x minus 12 equals 0. Now we need to do some factoring. So this is going to be no GCF. We have 3 terms, so we're going to do general factoring. So it's going to be x. If you do your smiley face method, you're going to get x plus 4 times x minus 3. Okay. And then we have to solve this now. So each part needs to be set equal to 0. So we have x plus 4 equals 0, or x minus 3 equals 0. Subtract 4, add 3. X equals negative 4, whoops, or x equals 3. Now we need to check for extraneous solutions. And the only reason you would get an extraneous solution is if you have a negative log, okay? That's what we're looking for. So we're going to plug in log of negative 4 plus 2 plus log of negative 4 minus 1 equals 1. Well, you can see here now we're going to have log of negative 2 plus log of negative 5 equals 1. So this is going to be, negative 4 does not work. It's undefined. Can't have negative logs, okay? Or logs of negative numbers. Let's check 3, though. So we have log of 3 plus 2 plus log of 3 minus 1, which equals 1. That's log of 5 plus log of 2, which equals 1. While log of 5 plus log of 2 equals log of 5 times 2. And 5 times 2 equals 10. And what's log of 10? Well, 10 to the first power equals 1, so this is going to work. So 3 is going to be our answer for this one. Okay. Last example, this one's a little bit easier. We have natural log on both sides. If you have a natural log on both sides, or the same log on both sides, or you have the same power on both sides, you can just set the exponents or the whatever's in parentheses equal to each other. So that's all we're going to do. We're going to do 3x minus 10 equals x plus 4. Solving for x now, we're going to subtract x, add 10. So we get 2x equals 14 divided by 2. And we get x equals 7. If you were to plug this into your extraneous solutions, it will work out, but let's go ahead and do that really quick. We have natural log of 3 times 7 minus 10 equals natural log of 3 plus 4, or 7 plus 4, whoops. So then we get natural log of 11 equals natural log of 11. And there's going to be our answer, so that you can see that this works out to non-extraneous solution. Okay? So extraneous solutions in this case are going to be negative logs of negative numbers. All right, last example is kind of a tricky one, but we'll get through it together. So let's go ahead and get through this here. A man invests $5,000 in an account that pays 8.5% per year, compounded quarterly. How long will it take for his investment to double? So we're going to use the formula. Actually, y, whoops. Y equals P, principal, times 1 plus R over N to the NT. Okay, so we need to label what we know here. So $5,000 is what they invest, that's your principal. 8.5% is your R, it needs to be converted to a decimal, which is 0.085. Compounded quarterly, that's your N, equals 4. And investment to double, this is a little tricky. So how long will it take? We're looking for T for his investment to double. If he invests $5,000, what's double $5,000? That's going to be Y equals 10,000. Okay, that's what we're looking for. That's not what we're looking for, but that's what we want the ending result to be, which is going to be your Y. So let's plug this in now. So we're going to do Y was 10,000. That's what we're going to end up with. Equals 5,000, which is our P. 1 plus R, which is 0.085. Divided by N, which is 4. 4 compounded 4 times a year. And then we have 4T. All right, so now I need to solve for t, which is kind of tricky because t's in the exponent here. So we're going to, first thing I would probably do is get this part by itself, the 1 plus 0.085 over 4 to the 4t. So I'm going to divide both sides by 5,000 to get that part by itself, okay? So now I get 2 equals, and that's going to be 1 plus 0.085 divided by 4 is approximately 1.02125. All to the 4t. Okay. And now what I have, now I have this. Now I need to, yeah. So I guess you can do log or natural log for this stuff here. We'll do natural log for this one. So yeah, natural log or log works for this. You can do either one. So we're going to do natural log on both sides to get that 4t down where it's supposed to be. So natural log of 2 equals, and then we have natural log of 1.02125 all to the 4t. This 4t drops down in front by properties of logs. Oops. So we have natural log 2 equals 4t times natural log of 1.02125 divided by natural log on both sides. That's a number, right? 1.02125 on both sides. And we're going to get approximately 32.96 equals 4t. Divided by 4, oops, to get t by itself, and t is going to be approximately 8.24 years. And there's our answer, okay? So it's basically just a similar problem we were doing before. We just need to get the 4t down in the, not in the superscript. We need to get it down on the same level as the, log and the other stuff, the other numbers. And so using natural log or log will help you do that because you can bring the exponent down in front. And in this case, we're looking for time, which is up in the exponent. So we're going to need to use log or natural log to do that. Okay? Well, that's all I have for you today. Thank you for watching. Have a great day, and we'll talk soon.